Hello everyone, welcome to this video. This is the seventh video in the GRE Big Book Quant series. What we are basically doing is we are going through the quant sections of each of the GRE Big Book tests. There are 27 tests and each test has two quant sections. So overall there are going to be 54 videos and this is the seventh video in that series. Alright, so in the description you will find the link to all previous videos. We will recommend that you go in a particular order, but make an effort to solve these questions as you are watching the video. That will give you the maximum benefit from these videos, right? So let's get started. As you can see here, this is Big Book Test 4, Section 2, 30 minutes, 30 questions. Okay, let's get started. Question number 1, 2% of 3 plus 5, that's basically 2% of 5, and this is 3% of 2 plus 3, that is 3% of 5. Okay, 5 is a positive number, that's important because otherwise we can make the comparison. For a positive number, higher the percentage, higher the number, correct? So obviously 3% of 5 is going to be bigger. If it was minus 5, then it would have been the other logic. Okay, let's look at this. So this answer here is B because this quantity is going to be bigger. Okay, let's look at B. Not sorry, B. Question 2. 6 by 7 minus 5 by 6. Okay, 5 by 6 minus 6 by 7. Okay. One thing I notice here is these are the same numbers that they are comparing, right? So essentially what they are saying is this is A minus B and this is B minus A. We want to find out which number will be bigger. Okay, so let's do that. Is 6 by 7 bigger or 5 by 6 bigger? Correct. That's essentially what the uh, question is. How do we compare two fractions? Basically, we cross multiply. Okay, so I do like this. So what do I get? I get 36. I do like this. What do I get? I get 35. 36 is bigger than 35. So 6 by 7 is bigger than 5 by 6. Okay, there are other ways of doing it also, but yeah, 36 is bigger than 35. Okay, so 6 by 7 is bigger. If 6 by 7 is bigger, then this is going to be a positive number, 6 by 7 minus 5 by 6, and this is going to be a negative number, right? So the answer here is going to be A. Okay, if you didn't want to do all this, what you could have also done is you could have also just uh, found out the value of this. How would you do that? That would become, okay, would be 36 minus 35, 1 by 42. That would have been the value here, and here the value would have been minus 1 by 42, right? Because essentially it's the same calculation, the order is different. Again, you would have got the same uh, number, same answer. Okay, all right, let's see question 3. 2y minus x is equal to 11. Okay, x minus 2 is equal to 5. So this looks easier. This is x is equal to 7, right? X minus 2 is equal to 5. Okay, so if I put 7 here, what do I get? I get 2y minus 7 is equal to 11. That means 2y is 18. That means y is 9. Okay, let me put both of these numbers back and see if that is making sense. So 2y is 18 minus 7 is 11, correct? X minus 2, 7 minus 2 is 5. Okay, fine. So my calculation is correct. What is bigger, x or y? X is 7, y is 9. 9 is bigger than 7. Answer choice B. Pretty easy. Question 4. The remainder when 48 is divided by 5. So 48 is divided by 5. What is the closest multiple of 5 that is lower than 48? 45. Correct? 5 nines are 45. The remainder is 3. Okay. The remainder when 48 is divided by 7. Okay. What is the multiple of 7 that is bigger than less than 48? That's going to be 42, right? 7 6 are 42. Okay, so here the remainder is 3. 6. Okay. So what is the bigger remainder? 3 versus 6. Answer choice B. Okay, xy is equal to 0. All right, and x is equal to 0. Interesting. So if x is equal to 0, xy always has to be 0. It doesn't matter what the value of y is. It could be positive, it could be negative. So I have to compare 0 with y. It could be positive, it could be negative. Let's take two cases. It could be x is equal to 0, y is equal to 2, correct? Or it could be x is equal to 0, y is equal to minus 2. Or it could also be x is equal to 0, y is also equal to 0, right? So we can't really determine. Answer choice D. Okay, let's look at question 6. Root 38 plus root 45. Okay, I don't know what root 38 is, but I know root 36 is 6. So what does that mean? That means this is going to be 6 point something, right? Okay. What is root 45? Again, root 45 is, what is the closest number here? Root 49 would be root 7. Sorry, root 49 would be 7. So again, this is going to be 6 plus something. Okay. 45 is bigger than 36 but less than 49. So root of 45 is going to be something between 6 and 9. So this is 6 point something, 6 point something. This is 12 point something to be compared with 12. Obviously, answer choice A. Correct? Okay. Okay. Lot of numbers here. Question number 7. Lot of angles. I know that some of these angles are uh, opposite angles to each other, right? So that's one observation. M is equal to Q. Okay. So M, I know M is going to be equal to R because they are opposite angles, but they are also saying M is equal to Q. So basically all these angles are same, X, 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 right? M is equal to Q, Q opposite is T, so that also has to be equal, and M opposite is R, that also has to be equal. So all these are X, 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 and T is equal to 50. Okay, so X is equal to 50. So they have already told us. So these are all 50, 50, 50, 50. So if I look at this line, what do I have? I have this angle is 50, this angle is 50, so that's 100 degrees. So this angle has to be 80 degrees because they all have to add up to 180, right? So same thing, if this is 80 degree, this is also 80 degree. So I think I got all the angles now. Okay. You could also do it with respect to this line, right? In this line also, 50 plus 50 plus 80, 180. Okay. What do I have? Q plus R. What is Q? That is X plus X. That is 100. What is S? S is 80. What is bigger? Answer choice A. Pretty easy if you figure out these angles. Okay, let's look at question 8. X plus 2y by 2. Let's solve this. So that's going to be x by 2 plus y. Okay, I don't think I can simplify this any further. Let's look at this. Let's simplify this also. 2x by 4 is going to be x by 2 plus 4y by 4. That is plus y. Okay, I get the same expression on both sides. So answer choice C. Now here I don't have to worry about whether it is negative, positive, 0. Okay, because it's the same expression anyway. The numbers could be positive, negatives, whatever. We don't have to compare the numbers. We just have to compare these expressions. Okay. All right. Let's move to question 9. PR is the diameter of the circle. Okay. So PR is the diameter. That means the origin is exactly in the middle. All right. And QR is a tangent. QR is a tangent. So tangents meet a circle at 90 degrees. So this is 90 degree. All right. How about QR? We just know that it's tangent. Okay. We don't know anything about whether PR is equal to QR. How far is Q? That we all don't know. Okay. Let's look at this. The length of PR, that is the diameter, and length of QR. Okay. Length of PR and length of QR. As I said, there is nothing that tells me something about QR. It could be the same as the diameter. Let's say this was 10 units. This was also 10 units. Okay. In that case, answer would be C. Or it could be something really big, like this. Okay. Or it could be something really small, only this much, right? I don't know. Either way, it could go. So the answer is answer choice D. Cannot be determined. All right. Question number 10. The toll for a certain bridge is 15 cents. or one token. Okay, so either give you 15 cents or give me one token. Tokens are sold in packs of 40 for $4. So that means $4 by 40.1 dollar. That means 10 cents is what I get a token for, but I have to buy them in packets of 40. All right. Okay. The person basically they are saying buy tokens. Okay, if you don't have tokens, give me loose cash of 15 cents. All right. The person saved on 40 trips across the bridge if a token rather than 15 cents is used to pay each toll. Okay. So if I use sorry, not dollars, yeah, 15 cents. 15 cents if I use, how much do I pay? I pay 15 into 40 trips, right? So that is $6 is what I end up spending. If I use 10 cents tokens, I get 40 trips for I have to buy 40 a pack of 40, right? So I'll be able to get 40 trips in $4 because that is the given cost. Okay, so how much do I save? I save $2 over uh, otherwise I would have had to spend $6. Okay, that's how you calculate. Okay, percent saved, right? The saving will be without tokens. If you do versus with tokens savings, what is that percentage? Okay, so the savings here would be 33%. Okay, percentage savings. So this is 33 one third actually, right? Technically, and this is 66 two third. Okay, obviously this number is bigger. Answer choice B. Okay, uh, you could have directly also done it comparing that every time I spend without tokens I spend 15 cents, with token I spend 10 cents, so my saving is 5 cents for every 15 cents, right? uh, and we would have got the same 33.33. Okay, there are multiple ways of doing this. Okay, so let's move on from here. Question 11, the area of rectangular plot A. Okay, this is plot A. What would be the area? The area would be n plus 2 into n plus 2. Okay, and here area of plot B, that would be n plus 3 into n plus 1. Okay, and to compare that, let's take some value for n. Let's say n is equal to 2. So this is going to be 4 by 4. So this is going to be 16. If n is equal to 2, this is going to be 5, this is going to be 3, this is going to be 15. Okay, so answer A. Okay, but will that always work? To make sure that this always works, it will always work because there is no complication here. This is pure multiplication. But there is another way without picking numbers, and that is to actually find out what would n plus 2 into n plus 2 be. Okay, so that's going to be n plus 2 square, that's n square plus 4n plus 4. And here if you multiply, you're going to get n into n plus 1. So that's n square plus n plus 3 into n plus 1. That's 3n plus 1. So basically what you get is n square plus 4n. Sorry, this should be 3 plus 3. Okay, so if you compare that, you get that this number is always going to be 1 bigger than this number because these quantities are the same. Okay, so here we have 4, we have 3. The difference will always be 1, right? Here also difference is 1. You can pick some other number also, let's say 5. That's going to be 7 into 7, 49. Here it's going to be 8 into 6, 48. See, the difference always comes out to be 1 short in plot B. Okay, so answer is A. Okay, the arithmetic mean, arithmetic cost, the average arithmetic mean cost per cassette for 18 cassettes costing total of 2x dollars. Okay, so total is 2x. For 18, arithmetic mean is going to be x by 9. Okay, I got this. Average arithmetic cost per cassette of 3 cassettes divided by 3, costing total of x by 3. So x by 3 is the cost, divide that by 3. What do I get? If I get this 3 down, it would be x by 3. I'm getting the same quantity again. Answer choice C is the correct answer. Okay, all right. Square QRST, QRST, this is a square, has perimeter P. Okay, What is the perimeter of a square? That is 4 times the side. Okay, so 4 times the side, 4s is equal to p. So each side is going to be p by 4. Right, p by 4, p by 4, p by 4, p by 4. Okay. Again, I also know that this triangle is a Pythagorean triangle. So what can I say? I can also say that x square plus y square is equal to hypotenuse square, that is p by 4 square. Correct? Okay, so that is x square plus y square is equal to p square by 60. That means information I derived. Now what do I have to do in the question? X square plus y square and p square by 60. They are equal, as I found out. Okay, so these quantities are equal. Answer choice C. Okay, question 14. Let me change the color. N is an integer and n is less than 0 but greater than 0 but less than 3. So there are only two such integers, right? Integer 1 and integer 2. Okay, so for both I'll find out this number. Okay, so when n is equal to 1, what do I get on left hand side, right hand side? When n is equal to 2, what do I get on left hand side and right hand side? Okay, so left hand side, as in column A, when n is equal to 1, I get 1 plus 1, so 1 by 1 plus 1 raised to 1. So that is 2 raised to 1, I get 2. On right hand side, I get a constant number, that is 2 plus 1 by 8. Is easy to do it in decimals. 1 by 8 is 0.125. So it is 2.125. Okay, this is fixed actually. So here I got 2, I got 2.125. Okay, answer is B in this case. In this case again also right hand side I have the same number. Okay, left hand side what do I get? Left hand side when n is equal to 2, I get 1 by 2 plus 1 raised to 2. Okay, so that is 1.5 square, that is 2.25. So 2.25 as compared to 2.125, I get A as the answer. Okay, so I'm getting two different answers in two different cases. Answer is going to be D. So this is a little meticulously, you need to figure this out. Okay, if you do some calculation mistake, you might get it wrong. Okay, but otherwise it's a pretty straightforward question. Let's look at question 15. Okay, interesting. All these are angles, external angles. They are all same. Okay, intuitively, if external angles are same, internal angles are going to be same, so it's going to be 60 60 60. Okay, but let's say you didn't catch that logic, and some same thing here also. Okay, let's do it all by calculation. So what do I get? If this is x, this is 180 minus x, and this same thing 180 minus x, 180 minus x, right? So there I have 3 times 180 minus x if I add them up, and that has to add up to 180. Correct. So basically 180 minus x is equal to 60. So x has to be 120. If x has to be 120, let's also find out y. Then we'll be able to get into the actual question. So same thing here. This is 180 minus y and 4 times of that. Correct. It was 3 times here. This was 4 times here. Okay. So note that 4 times of 180 minus y is equal to, now this is two triangles, right? So this is 180 degree plus 180 degree, 360 degrees. Okay, so don't think it is 180, 360. So basically 180 minus y is equal to 90, right? So y is going to be 90. Okay, like I said, intuitively we could see that this is a square and this is an equilateral triangle, so it has to be 60 60 60 here and 90 90 90 90 here. But we also could calculate that. Okay, so that gives us more confidence. Now let's do it. X minus y is 120 minus 90, so that is 30, and x plus y by 7, x plus y is going to be 120 plus 90 by 7, that is 210 by 7, that also gives us 30. Okay, so answer choice C, both quantities are equal. Let's move on to question 16. Question 16 has this shoes sold by some company. Okay, let's say 16. If 8750 pairs of shoes are represented in the pictograph above, how many pairs does one shoe represent? Okay, so how many shoes do we have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and this is half a shoe. Okay, so 12.5x, let's say x is every one shoe. 12.5x is equal to 8750. Okay, so I'll have to do 8750 divided by 12.5. So 12.5 is 25 by 2. So I write it as 25 by 2. Okay. That 2 from denominator comes to the numerator, right? So that is basically going to be, what is this? So this is 3, 350 into 2 is equal to 7. Okay, 7. Verify this calculation always. You have enough time. Anyway, the numbers are fairly straightforward on the GRE, but still always verify. Okay, what you could do is you could do 350, multiply that by 25, and you will get this number. Okay, same thing you do with squares and square roots if you are not very sure. You will have enough time for that. Okay, so this is 700. Let's move to question 17. If x is equal to 3 and y is equal to minus 3, okay, what is the value of this expression? Let's find it out. X, this is 3 plus x, so that is 3 plus 3 is 6 into y, sorry, 3 minus y. So what is 3 minus minus 3? 3 minus minus 3 is also 3 minus minus 3 is minus 6, right? Am I doing some mistake? Oh, sorry. This is not y minus 3. This is 3 minus y. So 3 minus y, like this. So it's going to be 6. It's going to be positive 6. Okay, 6 into 6 is answer choice E, 36. Correct? Verify that, because sometimes in the flow of things you tend to miss something, especially with the negative signs and everything. 3 minus y is going to be 6. Correct. I'm right. Question 18, 6 square minus 4 square by 2 square. Okay, very easy number. So let's just write the numbers. 36, 6 square is 36, minus 4 square is 16, 2 square is 4. So that is 36 minus 16 is 20, 20 by 4 is equal to 5. Okay, if these were some odd numbers, you could have also done it using algebra. For example, you could have said this is of the form a square minus b square. So the answer is going to be a plus b into a minus b. So that way it could be 6 plus 4, that is 10, into 6 minus 4, that is 2, divided by 4. You would have obviously got the same answer again. Answer choice E. I think we have done similar question in one of the earlier tests, maybe test 1 or test 2. See, as you will solve more and more questions, you will see that the type of questions are repeating. The exact same question obviously will not come again, but the logic and the types, they are repeating, and that's the whole value of practicing. Okay, let's look at question 19. If the area of the circle is 25 pi, okay, so let's say the radius is r, area of the circle is going to be pi r square, that is 25 pi. Okay, so pi gets cancelled, r square is 25, so r is 5. Okay, radius is 5. Then the diameter is going to be, if radius is 5, the diameter is going to be 10 units. Okay, answer choice D. Okay. Uh, you might go wrong if you think this is circumference of the circle. Okay, for example, if you misinterpret this as circumference is 25, okay, 25 pi, so pi will get cancelled. 2r is the diameter, that is 25, and you might mark 25 as the correct answer, but that is wrong. Okay, because this is not a circumference, this is the area, right? So be always very careful with area and circumference. Okay, question 20, in the figures above, the area of square region wxyz, wxy, this is square, okay, is equal to the area. What is the area here? 6 into 6, 36. 36 is the area of this triangle also. It's equal, right? So that means half into RT, half into base into height. Height is 9, that's 36. Okay, so pretty straightforward. What is RT? RT is going to be 36 into 2 divided by 9, so that's going to be 8. Correct? 36 2 is 72, 72 by 9 is 8. So RT is equal to 8. Question number, sorry, option choice E. Let's look at the graph questions. Question 21 to 25. Visitors to and from the US in these years. Okay, 71 to 71, 81. Number of visitors from the US to Europe. Okay, in 1971, 3.2 million visitors went to Europe from the US. Like this. Okay, it went down for some years, again went up, then went down. Okay, this is from the US, and this is all foreign visitors to the US. Okay, number of visitors in millions again. So in 1971, 13 million or 12.5 million visitors, foreign visitors came to the US, and this number has generally been increasing. Okay, one thing to note is that this is US to Europe, and this is all countries to the US. Okay, so obviously these numbers are likely to be much bigger. Yes, these are only till 5 million. They start from 12 million. Okay, so fine. Is there any third graph? No, that's it. Seems pretty straightforward. Let's look at the questions. The total number of total visitors from the US to Europe. Okay, so that is this graph from US to Europe. Total visitor from US to Europe for 73 and 74. Okay, so I need to get 73 number, 74 number. Okay, what would that number be? That's going to be this plus this. What is that? That's about 3.6 plus 3.2, something like that. Okay, that's total number was most nearly equal to the total number for which of the two following years. Okay, so they have given pair, and I have to also find out the sum here and suggest which of them was closest. Okay, so this is going to be something like 6.8 total. All right, let's look at the answer choices: 76, 77, 77, 78, 78, 79. So they are kind of in sequence, 79, 80, 80 to 81. Okay, so let me see if I can figure something out here. Where does it start? It starts from 76. Okay, so 76, 76 and 77. I think they are very close, right? These two numbers are very close. Okay, so this is a good answer choice: 76, 77. 77, 78. No. Why? Because 77 and 73 are same, but 78 is much bigger compared to 74. Okay. And then here, any of these two pairs are going to be much bigger because uh, as you can see, they are all greater than this main figure, right? If I take this as a reference, right, I need something like 3.2 here. None of these figures are like 3.2. So the closest answer is 76 and 77. You can also do it math wise. If this logic wasn't there, the ideal way would have been to add up these numbers and see which one sort of is closest to this given pair, the total of this given pair. But you didn't have to do that because of that logic. Question 22, there were approximately how many million more foreign visitors to the US in 80 than in 75? So I need to get 75, I need to get 80, and I need to find out how many were more. Okay, total. So in 80, what is the number? 80, I had 22 million. And what is the other year? 75. 75, I had 15 million. Okay, so I had 7 million more. Approximately how many million more foreign visitors to the US in these 2 years? Okay, 7 million. Answer choice D. This is kind of on the easier side, this whole set. Even the graphs are pretty straightforward. In 1980, there were 17.1 million foreign visitors to New York City. Okay. Do I have any information about New York City here? No. This is all about United States, the total United States. Okay. All right. So this is some extra information. In 1980, all foreign visitors to New York City was 17.1. That was approximately what percent of total foreign visitors to the US? Okay. They have not given the year, so I'm assuming it's the same year. So 1980 New York versus total. Okay, so 1980 we found out this was 22 million, right? Uh, 17.1 million in New York City, 22 million in total. What was that percentage? Correct? Okay, so let's find this out. Easiest way is to multiply this by 4 so that you get this close to 100. If you multiply 17 by 4, you get 68, right? Roughly I'm doing. Okay. But I'm still falling short, so I need to add, let's say I add 10% more on both sides. Okay, so I add 9 here. What do I get? I get 97. Okay, I get 10 more here, 10% more here. I need 7. I add more 7 more here. So what does that give us? 7 more here, I get 75. Okay, and obviously if I drag this closer to 100, I'm going to get a number something more than 75%. Okay, so what is the number more than 75%? 78%. Okay, it's definitely not close to 88. Okay, but you can also do the calculation. I mean, you can take, let's say you take 78 and multiply that by 22. Do I get, um, is that correct? 78 of 22, right? Okay, then I should get 17.1 or something. You could do that also, but answer is going to be 78. Okay, let's look at 24. How many years after 1971 show an increase over the previous year? Okay, so 71, 72, is there an increase? 71, 72, is there an increase? How many such years there was an increase? In what? In both the number of visitors from US to Europe, that is the first graph, and number of foreign visitors to the US. Okay, so basically they are saying in how many years was there an increase in both the graphs. Okay, interesting. So there was an increase here. Was there an increase here? Yes. So that is 1. Here I have an increase. Here I have an increase. So that is 1 more. Here I don't have an increase. Here I don't have an increase. So we'll have to skip that. Here I have an increase 3. Here also I have an increase 4. There also 5, 6. Here I don't have increase. Here I don't. Okay. So 6 years basically. Okay. 6 years. Okay. Let's verify because these are kind of tedious calculations or observations, so we need to be careful. Let's do it in a different color. One logic I can put here is that, see, this graph is generally rising and there is an increase except in this part, and yeah, except this part there is an increase everywhere. Okay, uh, correct? Is that correct? Yeah, so I'm going to leave out this part, this year here. Okay, and I'm just going to calculate the increase only from this graph now. Okay, because I have already looked at this graph. Understood the logic? So first I got all the increase years. All the increase years are from this graph are all years except this. So I remove this in this graph and just look at the increase years here. Okay, so let's just clear this out so that we can uh, look at this properly. Okay, so what year I'm dropping? I'm dropping this year. Okay, and I'm calculating all increase years. So that is 1, 2, 3, 4, 5, 6. Okay, again I got 6. So that must be the answer. I did it 2 ways just to verify. Okay. Question 25. In 1975, if 60% of foreign visitors to the US were not from Europe, okay, so 60% were non-Europeans, 40% were Europeans. This is incoming, okay, all foreign visitors in 75. Then the number of European visitors to the US, that is this 40%, was approximately how many times as great as the number of visitors from US to Europe. Okay, so let's first find out this 40% number. Okay, this is a little long to understand. In 1975, how many visitors came? 1975, this number came, so that is 15. Okay, 15 million. So 1975, 15 million came. Out of that, 60 were non-European. So 60% of 15, that is 9 million, is non-European. Sorry, non-European. European was 6 million. Okay, so in 1975, 6 million Europeans came to the US. Okay, now what do I have to do that? Then the number of European visitors to the US, that is this 6 million, was approximately how many times as 6 million is how many times of something. Okay, what is something? As great as the number of visitors from US to Europe, it is in the same year. Okay, so how many came from Europe to US? 1975, 3 million approximately. So 6 million is how many times of 3 millions? 2 times of 3 millions. Okay, it's a little complicated to plot exactly what they're asking. So you'll have to be very careful about what you're doing. So what answer is going to be answer choice A. Okay, let's move on. Question 26. If y is equal to 2x minus 1, okay, that is what is the value of x in terms of y. Okay, let's write in terms of x. If I get minus 1 here, what do I get? Y plus 1 is equal to 2x. So that means x is equal to y plus 1 by 2. Do I have y plus 1 by 2? No, no. This is not y plus 1. Yeah, this is y plus 1 by 2. This is not the case. This is also not the case, right? Okay, y plus 1 by 2 is this. Because the denominator is the same, so I can write it like this. Okay, answer choice C. In the given figure, what is the area of the shaded region? Interesting, area of the shaded region. Uh, Basically, area of the shaded region is this big triangle of base 2 and height 2 minus this small triangle of base 2 and height 1. Correct? Are you able to see that? See, this area is what? Is this big area minus this area. Okay. So let's find that out. Big area is half into base, that is 2, into height, that is 2, minus small area is half into base into height. Okay. 2, 2 gets cancelled, I get 2. This 2, 2 gets cancelled, I get 1. 2 minus 1 is equal to 1. Answer choice A. Right? Let's look at question 28. If n is equal to 15 into 28 into 26, okay, which are following is not an integer. There are all these numbers. Do I really want to find out the value of n and then divide that value by all these numbers? Is that would be one way of doing it, right? The easier way to do it is split everything in prime factorization. Okay, so let me write the 15 as 3 into 5, right? That's the only way to write it. 3 into 5 into 28 will be 2 into 14. 14 I can write as 2 into 7. Okay, into 20, 26. 26 2 into 13. Correct? Did I get it right? Yes. Okay. So there are all these numbers on top. Okay. Uh, can I, if I divide this number by 15, obviously I can, 15 would be what? 3 and a 5. Okay. So I can cross a 3, cross a 5, I'll get an integer. This is not going to be a non-integer. We are interested in finding the non-integer. This will give me an integer. And by 21, yes, 21 is 3 times 7. So there is a 3, there is a 7. I can cancel that. This is out. What is 32? 32 is 5 times 2. So 1, 2, 3, 4, 5. Do I have 5 twos here? I don't have 5 twos here. Okay, so I will not get an integer. So this is a good answer choice. Let's keep this. Answer choice D, 35. 35 is 7 times 5. I get a 7. I have a 7. I have a 5. So this is going to be an integer. 39. 39 is 3 times 13. So I have a 3. I have 13. This is also going to be giving me an integer. The only uh, expression that will not give me an integer is this, n by 32. Right? So that's going to be answer choice. Very interesting problem. Okay, see, the numbers could have been very bad looking numbers also, like big numbers. For example, it could be 56 or maybe 112 also. But the logic would have remained the same. So if they want to really increase the complexity of this number, they can write something like, let's take 750 or 750 into 112 into, I don't know, 130. Okay, then what? Then also, obviously the answer choices would and everything would change, but the method would remain the same. It's equal, that this problem and that problem would be equally uh, will be equal in terms of difficulty level, in terms of the in terms of the time, difficulty level, logic, and everything. They are all going to be same, but this is going to look more intimidating to a test taker. Okay, they have not done that, but I'm just giving you the finer insight into how some questions can look tricky, but actually they are not so tricky. All right, let's look at question 29. So far, I'm not seen any super difficult question here. It's a typical GRE big book type of difficulty level. Okay. Question 29. How many positive integers less than 20? Okay, that means 1 through 20. How many of those numbers? Okay, now 1 through 19. Okay, less than 20. All right. Are equal to the sum of positive multiple of 3 and a positive multiple of 4. Okay, interesting. So I need to get a number which is a positive multiple of 3 plus a positive multiple of 4. Let's first find out what is positive multiples of 3. So 3, 6, 9, 12, 15, 18. Okay, then I get out of range because I'm interested in only till 19. Okay, so these are all multiples of 3. And what are multiples of 4? Going to be 4, 8, 12, 16, and 20. Okay, so I need to find out how many of these numbers, now 1 to 19, can be made by adding one number from here and one number from here. Okay, now it's going to take a lot of time for us to figure out, okay, does one, can I get one, can I get two, can I get three, right? That's good. I'll have to do that 19 times, and there also I might make some mistake. Instead of that, let's first find out what all numbers I can make. Okay, that's what they are asking now, how many numbers can be made. So let's see. So let's start with 3. I'm going to add 3 to everything. I'm going to do 3 in blue. So if I get 3 plus 4, I get 7. 3 plus 8, I get 11. 3 plus 12, I get 15. 3 plus 16, I get 19. Okay, let me take a different number for 6. So I get 6 plus 4, I get 10. 6 plus 8, I get 14. 6 plus 12, I get 18. Obviously, there are going to be some numbers that will repeat. 6 plus 16, 22. I'm not interested in that because I am interested only in 19. Okay, next number 9. 9 plus 4, 13. 9 plus 8, 17. 9 plus 12, out of bound. Okay, let's look at 12. 12 plus 4, 16. 12 plus 8, 20, out of bound. Then I look at 15. 15 plus 4, 19. Then 15 plus 8, out of bound. And then I look at 18. 18 plus 4, out of bound. So essentially I got only these numbers, but I need to remove any overlap if there is any. Okay, so 7, 11, 15, 19, 10, 14, 18. 19 is one number that is repeated. 17, no, 19 is the only number that's repeated. That means 19 can be formed by different combinations of these numbers. Okay, is there any other number? 7, 11, 13, 15, 17, 15, 10. Okay, fine. So how many such numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 such numbers. Now, this was a very different type of problem that I have not seen on GRE Big Book series so far. Okay, so I like this question. Okay, it was something different. It required you to, it's not a difficult question to figure out, but it's very methodical. If you make some mistake or if you try to do it the other way, for example, can one be formed, can 2 be formed, can 3 be formed, right? That's a very long process and prone to error also. And the answer choices are also kind of, I mean, if you miss couple of these out of these 10, if you miss couple of these, or uh, if you don't add the remove the overlap, okay, I think one interesting answer choice could also have been 11, because if someone forgets to remove the overlap, then and they just count it, maybe they'll mark 11. So fairly, there are a lot of sort of landmines inside this question where you could go wrong. I like this question. Let's look at the last question. Question 30. Two tanks X and Y are filled to capacity with jet fuels. Okay. X holds 600 gallons more than tank Y. So X is 600 more than Y. if 100 gallons of fuel were to be pumped from each tank, okay, that means x minus 100 and y minus 100, okay, if that much was removed, then tank X would then contain 3 times as much as tank Y. Okay, so I get this equation. What is the total? Total means they are asking x plus y. Okay, so let's first start from here. So x minus 100 is equal to 3y minus 300. Okay, let me replace x as 600 plus y minus 100. So here I'm replacing as 600 plus y. 600 plus y minus 100 is equal to 3y minus 300. Okay, let me get y on this side, so this y becomes minus y. I get 2y here. Let me get all the numbers on this side, so I get 600 minus 100, that is 500. 500 plus 300 is 800. So 2y is 800, y is 400, x has to be 600 plus y, that's 1000. Okay, let me put these numbers back to see if they are making sense. Is 1600 more plus 400? Yes. In the second scenario, this would be 900 is equal to 3 times y minus 100 is 300. Is 900 equal to 3 times 300? Yes. That means these numbers are correct. Okay. But what are they asking? They are asking for not x and y. They are asking for total. So that is 1000 plus 400, 1400. Okay. Don't mark 1000. That would only be x. Okay. So always be careful what they are asking. Okay, so we did one more set in this series. As I mentioned a few questions ago, this was a, a typical GRE Big Book test. Okay, slightly on the easier side, right? Nonetheless, great practice material because you get some different type of questions every now and then. For example, this question, as I mentioned, was fairly new in terms of its construct and the type of logic used. Okay, what else? The numbers here were the graph was really straightforward, but I think there was one question in the graph that was slightly calculation intensive. Yeah, this one. But yeah, I mean, you can still figure it out. Always verify your calculation. That's one thing that we have seen. Okay. This one also I've not seen this kind of a question, but this was very easy to figure out. This calculation is, I mean, it's doable. It's not very, very difficult. Okay. This was fairly logical. Okay, this was also decent. Um, yeah, I mean, this was little required you to do some calculation. Nothing sort of, unexpected. That's how I would put it. Fairly straightforward in terms of what to expect on the GRE. Okay, so hope you have been solving along. That's the best way to derive value from these videos. Okay, don't just watch them for the sake of watching, because then that's going to give you a false sense of preparation. You might be thinking that, okay, I know this, but the type of errors that you will make here, uh, that is the real value. When you make an error, you have some learning point. If you don't make an error, that's fine. But that doesn't really mean anything, because sometimes you might just guess, or maybe you think you solved it the correct way, you solved it the wrong way, but you still not got the correct answer. So it doesn't really mean anything. It's only when you get something wrong, then you realize something, whether it's a conceptual error or some sort of an problem in terms of interpreting the question, or maybe a silly mistake, or whatever it may be. Right, there is some value for you. So do solve these questions as I'm solving. Okay, and I'll see you in another video.